Good morning, grade 6 students. This is your teacher, Miss Rita. Today we will start explaining a new lesson, electric circuit. So please open your books to page 175. Today we will learn what is Ohm's law and we will solve some exercises. Ohm is a scientist who conducted different experiments and he concluded that even when we change the voltage, the resistance of a conductor does not change, it is constant. So from this, he concluded that the current, the voltage, and the resistance are always related in the same way. The following triangle shows you the relationship that Ohm concluded. From this, we can extract three equations. The voltage U is equal to the current times the resistance, and it is in volts. The current is equal to the voltage divided by the resistance in amperes, and the resistance is equal to the voltage divided by the current in ohm. Let's solve page 175, figure 1. You have the following table. From the table, you need to predict the relationship that Ohm found. Let's take the first line of the table. When the voltage is equal to 6, the current is 2 amperes and the resistance is 3 ohm. If we try to multiply the resistance, which is 3, by the current, which is 2, we get 6, which is the voltage. So from the first line, we can conclude that the resistance times current is equal to the voltage. Let's see if this equation applies to the rest of the lines. 4 times 1.5 is equal to 6. And so on if we continue for the rest of the lines. So from this table we can predict that Ohm's law says that the voltage is equal to the resistance times the current. Let's solve page 176 to the math. A multimeter is a device that can measure the current in a circuit. It's the red device that you can see in front of you. We use it to get the current, to measure the current. Use the reading on the multimeter and the battery to find the voltage and current in the circuit. So as you can see, on the multimeter we can read 6.54 amperes, which is the current, and on the battery we can read 6 volts, which is the voltage. Now, the second part of the question is to calculate the resistance of the bulb. So the resistance is equal to the voltage divided by the current, which we previously learned. So we simply have to divide 6 volts by 6.54 amperes. We get 0.92 ohm. Part 2. Batteries gradually lose voltage. This is why you have to change batteries. Sometimes they die, they stop working. They lose their voltage. A circuit contains 2 ohms of resistance and an old 9 volts battery. 4 amps of current run through the circuit. Now we have to calculate the actual voltage. The actual voltage of the battery is the current that is passing through multiplied by the resistance. So the resistance is 2 ohm and the current is 4 amperes, which means that the voltage that the battery is giving is equal to 4 amperes multiplied by 2 ohm. We get 8 volts. Part 3. Suppose you tripled the voltage in a circuit. Tripled means that the voltage is now times 3, but kept the resistance constant, so we didn't change the resistance. The current in the circuit would be triple, the same as or a third of the original current. So to be able to solve this question, let's calculate the original current. So the original current is equal to the voltage, which is U, times the resistance, which is R. Now let's calculate the new current. We're going to call it I1, and this new current is equal to the voltage, which is now 3 times the original voltage, so 3 times U, times the resistance, which is still the same. By comparing the new current and the original current, you can see that instead of U times R, we can write I. So we get I1 equals to 3 times I, which means that the new current is equal to 3 times the original current, which means the answer would be triple the original current. Now as homework, I need you to copy questions 1, 2, and 3 on your copybooks and try to solve them.